Hi guys, how are you all? Welcome to the channel Physics Classes by Sriraj. And this question is from a reference book of Concepts of Physics Volume 1 by the author of H.C. Verma. And the topic is work power energy. Question number is 43 from exercise. First, let me read the question. Figure shows a spring fixed at the bottom end of an incline of inclination 37 degrees. A small block of mass 2 kg starts slipping down the incline from a point 4.8 meters away from the spring. The block compresses the spring by 20 centimeters, stops momentarily, and then rebounds through a distance of 1 meter up the incline. Find A. The friction coefficient between the plane and the block, and B. The spring constant of the spring. Take G is equals to 10 meter per second square. And this is the diagram relevant to our question. Let us first look at this animation to get the proper feel of the situation. In this animation, the block is initially at rest and it is moved down by 4.8 meters along the inclination and then compresses the spring by 20 centimeters, that is 0.2 meters. This means the total distance moved down the incline is 5 meters. Then it bounces back by 1 meter and finally the block is at rest. It means net energy gained by block is 0. Therefore, the total work done by friction must be cancelled out by the work done by gravity, bringing the block downwards, which means work done by gravity is equals to the work done by friction. In this diagram, the weight of the block is mg, which acts vertically downward. Now I am resolving this mg into two rectangular components. One is along down the incline, that is mg sin theta, and one another is mg cos theta, which acts perpendicular to this mg sin theta component. And normal forces acts perpendicular to this inclination plane, and frictional forces acts always opposite to the direction of the motion. Here frictional force is mu into n, and normal force is balanced by mg cos theta component. So n is equals to mg cos theta. Now I am substituting this n value in frictional force. F is equals to mu into mg cos theta. Here work done by gravity is mg sin theta into d1. Work done by friction is mu into mg cos theta into d2. Here I can get rid of this mg from the both sides. Now the equation will be sin theta into d1 is equals to mu into cos theta into d2. Now I am considering this as the equation 1. Here d1 and d2 are, d1 is the net displacement of the block down the incline, which we can see 4 meters, and d2 is the total distance of the block moves on the inclined surface, that is 5 meters in downward direction and 1 meter in upwards direction. So the total displacement distance is 6 meters. Now I am substituting this d1 and d2 in equation 1, then it will be 4 sin theta is equals to mu into 6 cos theta. Mu is equals to 2 by 3 tan theta. Here they given that theta is 37 degrees. The tan 37 is 3 by 4. So mu is equals to 2 by 3 into 3 by 4. After the calculation, the mu value is 0.5. So this is the answer to our first part of the question. In the second part of the question, they are asking the spring constant. For that, now let us consider the motion of the block from the time to start to moving to time to compress the spring to maximum compression. Initially the block is at rest and gravity doesn't work to pulling the block down to incline while the friction dissipated some of this energy. Finally, when the compression in the spring is maximum, the block comes to rest again, so that the block does not have any kinetic energy. All the energy it had must be transferred to the spring. This means work done by gravity minus energy dissipated by friction must be equal to energy stored in the spring, which means work done by gravity minus work done by friction is equals to half kx square. Here work done by gravity is mgd sin theta minus work done by friction is mu into mgd cos theta is equals to half kx square. In the first part we got mu value is 0.5, and as we can see in the diagram, d sin theta is 3 meters and d cos theta is 4 meters. And now I'm considering this as a equation 2. If I substitute these values, and the maximum compression in the spring is 0.2 meters. If I substitute all these values in equation 2, we will get 20 into 3 minus 0.5 into 20 into 4 is equals to 0.5 into k into 0.2 whole square. After calculation, I got the k value is 1000 Newton per meter. And this is our answer to the question. Thank you guys. If you are interested on my video, subscribe to my channel and hit the bell icon to get the notifications.